So writing the base units or expressing the quantity in the base unit, that is, the last we did was a pressure. Another example, say power. What will be the base unit of the power? To write the base unit of the power. And the formula I will write if you don't remember. The formula, like it can be any you can use. For example, the power is work divided by time or energy divided by time. So what is the base unit of the power? The base unit of the power. So we have power equals energy divided by time. That's a formula. The power equals energy divided by time. The unit of energy. What is the unit of the energy? The unit of energy is joules. So we write joules and the unit of the time is equals to seconds. What is joules equivalent to? We just did that the energy or the joules is equivalent to kilogram meter square second raised power minus 2. And then second. So this is divided. It will move in the numerator. So this will turn out to be kilogram meter square second minus 3. So this will be the base unit of the power, which is kilogram meter square second raised to power minus 3. Is it clear, this one?
Yes, sir. Sure.
So like example, the unit of the force is Newton, and we can represent. So these are some base units are there. So as you can see, the unit of the force, that is Newton. This is a derived unit, and but we can equivalent to the base equivalent unit, which is kilogram meter second raised to power minus 2. Same way we have work or energy, the unit is joules, which is a derived unit, but the base unit is equivalent to kilogram meter square second raised to power minus 2. Electrical power or any power which is watt, the unit is the base unit is kilogram meter square second raised to power minus 3, and so on. We have a frequency, the derived unit is hertz, but the base unit is second inverse. A charge or a coulomb, that the base unit is ampere second, but the derived unit is coulomb. Same thing for voltage. The voltage, the unit is the derived unit is volt, but the base unit is kilogram meter square second raised to power minus 3 ampere inverse. And the resistance equivalent to kilogram meter square second raised to power minus 3 and ampere raised to power minus 2. Even for example, there was one question as a student asked, and that if we use electrical power, we'll get a different unit. But actually, it will give the same unit. Like when we use this formula, that power equals energy divided by time, our final answer was kilogram meter square second raised to power minus 2. So the final answer was kilogram meter square second raised to power minus 2. But what if you use a formula that power is a product of voltage and current, and you try to solve this? So volt is a derived unit. The base unit is kilogram meter square second minus 3 and ampere inverse. So this will be equals to kilogram meter square second raised to power minus 3 and ampere inverse, like ampere minus 1, that's equal to volts, and the unit of the current is ampere. So this ampere power 1 and ampere power minus 1 cancel out each other. So what we are left with, we are left with the same unit. So kilogram meter square second raised to power minus 3. So irrespective of the formula you use to get the base unit, you will get the same answer. It does not make any difference. So what is the difference between the base quantities and the derived quantities, so, or the fundamental quantities and the derived quantities? So you have these 7: the mass, time, length, electric current, temperature, amount of substance, and the light intensities. These are the base unit, these are the base or the fundamental quantities, and all 7 of them are known as the base unit. So if we represent any other, like we represent the unit in terms of these 7, we call that units as a base unit. But what is the derived quantities? Derived quantities are the one which consist of 2 or more fundamental quantities. Like when 2 or more fundamental quantities will combine, it will become a derived quantity. Example, let's speed. How you calculate the speed? So you calculate the speed by measuring a distance in time. So distance is a length, and time, so when like distance, which is a length, that is a base quantity, and time is also a base quantity. So when you have these two base quantities, when 2 or more base quantities are used to find another physical quantity, what we call that quantity, we call that as a derived quantity. So derived quantities are actually, we find them by using 2 or more base quantities. So that's the main difference between the fundamental quantities. So 7 of them classified as fundamental. Rest all of them can be found by using these, any of the 7 or 2 or more from the 7. We call them as a derived quantity. Is it clear, the difference between the fundamental and the derived quantities? Any doubt,
Yes, sir.
Ammar? Okay. Yeah, so the derived quantity is actually a combination of the fundamental. That's right. So 7 fundamental, rest all of them are derived. So the easy way to remember, just memorize 7 quantities as a fundamental, rest all of them will be the derived quantities. Then the prefixes which we use, as being a physics student, you have to represent your answers in scientific notations. Like some of the answers are too small, some of the answers are too big to write all the numbers. We used a notation, we call them as scientific notations. And you have to use, for these scientific notations, certain prefixes are used. So example, if you have 10 power 1, that is deca, 10 power 2 hecto, 3 kilo, 6 mega, 9 giga, tera, peta, exa, zeta, and iota, which is 24. Same way, if it is -1, it's deci, -2 centi, -3 milli, -6 micro, -9 nano, -12 pico, -12, -15 is femto, -18 is atto, zepto, and yocto. So these are the prefixes you have to learn, because sometime when they give you the magnitude of the physical quantity, so they use these prefixes. Till tera is okay, you learn, but I advise student to know all of them, because it's fine if you learn till tera, but I advise to learn till 24. So you have to learn these prefixes accordingly. Like example, if I say if I say 30 kilometer, so 30 is a magnitude, the numerical magnitude. Meter is a unit. But what is this kilo? This is actually representing the notation, the scientific notation, the exponent 10. So actually, how many meters are there? So kilo stands for 10 power 3. So it's equivalent to 30 into 10 power 3 meters, or 30 exponent 3 meters, or 30,000 meters, you can also say. So example, if you have a flash drive which is 8 GB, so 8 is actually representing the numerical magnitude. The byte is representing the unit. What G is representing? It's representing the notation, the scientific notation, giga. And giga stands for 10 power 9. So it is 8 into 10 power 9 bytes. Or 8 and then 9 zeros are there, and then byte. So these prefixes you have to learn. You should be able, because usually in the numericals, you have these prefixes given as, like the numbers are there, and you have to convert into the scientific notation. So it's important, you have to learn this. If you learn till 15, that's also fine, but I advise to learn till 24. Then there's another thing which is related to estimation. Some MCQs, some questions, you have to estimate the thing. So you have to understand the order. Like example, if we talk about the size of the solar system, it is in order of 10 power 13. Look, it does not mean the solar system is 1 exponent 13 meter. It can vary, but the thing is the order is in 10 power 13 meters. So you can compare anything with a solar system. Same way, the size of the Earth orbit around the sun, which is 10 power 11 meter, actually it's about 1.5 exponent 11 meters, which is also known as the astronomical unit. The size of the moon's orbit around the Earth is in a power of 8, like 10 power 8. The diameter of Manchester, that is 10 power 4. The human height means like 10 power 0 means it's anything raised to power 0 is 1. So it's like 1 meter and above. It's not like all are 1 meter. So it's in the order of the meter. So you should be able to compare the things, like the estimation is there, because in MCQ sometime you may have a question that estimate the height of the room. So if you estimate the height of the room, which thing is in comparison is much more easier if you compare the height of the room. So you can compare the height of the room with the human height. So human height is a more comparable factor which you can compare with. So when you select an option, you will select an option. Maybe it's 5 meters, maybe it's 6 meters, maybe it's 12 meters, but you'll compare in this order. Like you will have the options in exam, you'll have the options that height of the room is example 2 into 10 power 20 meters. One of the option, another one 2 into 10 power 10 meters. Another option 2 into 10 power say 0 meter or 1 meter. And another option is 2 into 10 power minus 6 meter. So which is the most comparable height? So this will be there. So you can compare the options. So that's why option 3 is more comparable. So these values, you have to go through these values, try to have an idea, try to have these estimations in your mind when you're predicting the other quantity. So the height of the ant, it's in 10 power minus 3 meters, which is a millimeter. A biological cell diameter 10 power minus 5. The wavelength of the UV light, the ultraviolet light, that is 10 power minus 8. The diameter of an atom, it's 10 power minus 10. And the diameter of the nucleus is 10 power minus 14 meter. So these things you have to learn, and then in MCQs, there will be a comparison and you will predict the thing related to these estimations. Is it clear, this idea about the magnitudes? Anyone having a doubt? Ammar, Aisha, Fabia, Ghulam, Mirab, Imad, Mirza Ammar, Muhammad Isa, Mubashir, Shahid.
No, sir.
No, no, sir.
Dimensions of physical quantities. Like when we represent the physical quantity, we represent the physical quantities in their base units. We can also mention the dimension. So the term dimension here refers to, like example, if any physical quantity, like example, if a length is involved, what is the dimension? How we represent the it's a short form for the physical quantity. So if the length is there, instead of length, we'll write L, capital L. Same thing, if the mass is there, instead of the mass, we'll write capital M. Instead of the time, we write capital T. Instead of the current, even though the current is represented by I, but we write the unit of the current, which is A. If any quantity, like example, a temperature is there, we use theta for the temperature. And if amount of substance is there, a quantity involve the amount of substance or mole, we write N. So for the physical quantities, for example, if I say speed, what is the formula for the speed? The formula for the speed is distance divided by time. What is the unit of the speed? The unit of the speed is because the unit of the distance is meter and the unit of the time is second. Meter per second. So if we move in numerator, it will be ms minus 1. So meter per second or ms minus 1 is a unit. But what about the dimension? The term dimension means like which physical quantity it represents. So how to write a dimension? We can write a dimension from the unit itself. Meter. Meter is a unit for what? Which quantity meter is representing? Which physical quantity the meter represent? So meter represent the length, L. Which physical quantity, the second inverse represent or the second represent? It represent the time. So it will be t minus 1. So what is the dimension of the speed? The dimension of the speed is lt minus 1. Means if I want to find the speed, I should know the length and I should know the time. So the purpose of explaining the dimension of the physical quantity is just to have a clear picture that what are the physical quantities I should know to work out or to calculate the magnitude of the other physical quantities. So if I want to find the speed, I should know the length and I should know the time. Is it clear? The concept of dimension? So we can work out the dimension
Yes.
from the units itself. Another example, if I want to say write the dimension of the force. So we have to state the unit and the dimension of the force. So first, what is the unit of the force? We know one of the unit is Newton. No, dimension does not, here in physics, the dimension does not refers to angle. Dimension is refers to like directions. Okay. Like, for example, if I want to find the force, what are the quantities I should have to calculate the force? The physical quantities, the base quantities, which I should know to calculate the final magnitude of the force. That means the dimension of the force. So example, the unit of the force is Newton, but what is the base unit of the force? The base unit of the force is kilogram, meter, second minus 2. So what are the dimensions? So what are the dimensions if I need the force? Kilogram represent what? Which quantity represent the like kilogram is representing?
Yes.
So kilogram is representing the mass. So I will write M. Which quantity meter is representing?
Length.
Length L. Which quantity second raised to power minus 2 is representing? It will
Time.
like so second is representing the time, but because it's raised to minus 2, so it will be minus 2. So the dimension of the force is ml t raised to power minus 2 or negative 2. Is it clear, this one? Anyone
Yes.
having a doubt or a question till this point?
No.
Okay. So can you state the dimension of energy or work? I will write the unit. Like the unit of the energy is joules, or joules can be represented as kilogram, meter minus 2, meter square is there, and second minus 2. So what are the dimensions of
So mass, length square, and time minus 2.
good? So because this is mass, this is length, so square, and this is t raised power. So the dimension is ml t raised power minus 2. So these are the dimension of the, there's no space actually. I'm just writing, it should be written all together like ml square t minus 2. So I should represent all together. No need for space between them. Now, if I say what is L in a dimension, what is L plus L? If I add length with L plus L, what I will get?
2L.
2L. L plus L should be 2L. But if I say L plus L is L, is it right? This is right. In dimensions, length plus length is length. For example, if I say I add 3 meters with 2 meters, what I will get? 5 meters. So means if a length is added to length, what I will get? Length. So in a dimensions, whenever we have the dimensions, when two dimensions, same dimensions are added, we'll get the same result. If length is added to a length, we will get the length. We'll not get any. For example, if length is added to a length, I will not get length square. I will not get the double length. So the dimension is actually representing a physical quantity. It does not represent the magnitude. It just represents a physical quantity. So if I add 2 meters to 3 meters, I will get 5 meters. So I will get a length itself. So in a dimension, length plus length or dimension plus dimension, I'll get the same. Is it clear, this part? So it does not make difference. What will be the answer for L minus L?
L.
So length minus length, dimension minus dimension, I will get L. So in our dimensions, when you subtract the two identical dimensions, you will get the same result. Because, for example, if 10 meters and you subtract 3 meters, so you will get 7 meters. So your final answer will be length. But what will be the L divided by L? What will be the answer? Yeah, just one question. I will answer that. There was, and this is a good question. You can ask your question if you have. Like, for example, if one student asks, if 10 meters minus 10 meters, what we'll get? We'll get 0 meter. That's right. But in a dimension, as I mentioned, in that case, if equal dimensions are subtracted, like 10 meters minus 10 meters, you will get 0 meter. You don't get the result, the final result. But this dimensions, as I mentioned in the beginning, does not represent the magnitude of the physical quantity. The physical quantity can have any magnitude. So even length subtracted with length, I will get 0 length. Means I cannot determine or I cannot determine the magnitude of that, but I should get a length, but that length is nothing. That's why we say 0m. So still I'm writing 0m. I did not say 0. I'm writing 0m. So the dimension is in length, but the magnitude is 0. That's the meaning of a 0m. So 0m does not mean 0, like magnitude is 0, but the dimension still is a length. So if a length is subtracted from the length, if 10 meters is subtracted from the 10 meters, which dimension I should get? I will get the answer 0, but I cannot say 0 second because 10 meters minus 10 meters, I cannot get the time. Same thing, I cannot say 10 meters minus 10 meter, I'll get 0 kilogram. No. If 10 meters minus 10 meters, I'll get 0 meters. So still, I should get a quantity, but the magnitude of the quantity is 0. That's why we can simply say that it does not have any answer here. Like it is, dimension is in length, but the magnitude is 0. Yeah, I said in the beginning, the magnitude and the unit both should be there with the physical quantity. So this physical quantity, we cannot determine, because if I say something is 0, it means I cannot determine it's there. That's why 10 meter minus 10 meters gives a 0 meter as a result. We cannot say that it's a physical quantity. Like 0 meter is not a physical quantity. But the dimension will be in the length. That's I'm saying. I'm not saying it does not have a magnitude will be 0, but the dimension will be in the length. So what will the answer for L by L? Length divided by length. Length divided by length. What will the dimension? I'll get 1. Means, yeah, it will be a number with no unit. Why? Length divided by length is a 1. It's just a magnitude, or it's just giving us a ratio. Example, you have 10 meters, you divide it by 5 meters. So when 10 is divided by 5, here 1 is actually refers, like it does not have any dimension. You cannot say any, instead of saying 1, you will say no dimension. No dimension means like it does not represent a physical quantity. It simply represents a ratio. So 10 meter divided by 5 meters. So meter cancel with meter, and 10 divided by 5, I'll get 2. So what is this 2? Actually, this 2 is representing a ratio. It's just showing a comparison that one object is twice as compared to the first one. But it does not give any idea about the physical quantity. It just shows a comparison. So when identical dimensions are divided with each other, when identical dimensions are divided, what we will get? We will get no dimension. Like we don't get a specific quantity, we just get the ratio of the quantities. So length divided by length is not 1 actually. It's just a ratio with no dimension. It's just a number. Is it clear, this example? Anyone having a doubt or a question in this? Then what about length multiplied with length? Length multiplied. So it will become dimension square. Means we get a new quantity which will have L square as a dimension. That is what happened. Like example, if I say that you have a cube or a cuboid, say one of the side is 3 meters, other side is 2 meters, and you want the surface area. So if you want a surface area, 2 meters multiplied by 3 meters, so 2 multiplied by 3 makes 6, and then meter square. So you got 6 meters square. So this was length. This is also length, but when you multiply, you get another dimension, you got an area. So when two dimensions, identical dimensions are multiplied with each other, we get a new dimension which represent or which may represent another physical quantity. So dimension of the length is L, but the dimension of the area is L square. So in the dimensions, remember, if L plus L, dimension plus dimension, dimension. L minus L, dimension. L by L, no dimension. And L multiplied by L, it will become square. So this is what happened in the dimension. But why this is important for us, why the dimensions are important for us, if we want to check the equations are scientifically correct or incorrect, we check the equations by using the dimensions. Say there is an equation, V equals U plus AT. Okay. This is the equation. This is an equation of the motion. Later in the chapter, you will learn. This equation is V equals U plus AT, where U is the starting speed, the initial speed. V is the final speed. A is the acceleration. And T is the time. So first, we will write the units. What is the unit of speed? Meter per second, ms minus 1. What is, this is U is there, ms minus 1 or meter per second. What is the unit of acceleration? It's meter per second square. And what is the unit of the time? Second. Is it clear? I just wrote here the units for each quantity. Any doubt till this point? I just write the unit. Unit of V, unit of U, unit of A, and unit of T. Then we can simplify this. As you can see, this is S and square, so it can be simplified. So it will turn out to be M by S. This will be M by S plus M by S. Now we write that this is in terms of unit till now. Now we write the dimension. So if we write the dimension, because meter is there, the dimension is length, and the time is there, which second is there, that's for time. Meter, length, time. Meter, length, and time. Now, if we simplify this, the left-hand side is already simplified. The right-hand side, I will write it here. If I simplify the right-hand side, if I take t as an LCM, the least common factor, so least LCM I took, so it will be L plus L. So what will be L plus L? So L plus L will be L. So the left-hand side dimension is equals to right-hand side dimension. So for the equation, if the left-hand side and the right-hand side dimensions are same, it means that this equation is homogeneous, or this equation is correct, scientifically correct. So how to check that the scientific equations are correct or incorrect? We check the dimensions of the equation, we check the left-hand side dimension, and we check the right-hand side dimension. If the two dimensions are same, like the both sides, the dimensions are same, it means the equation is dimensionally correct and it can be used to solve the problem. Is it clear, this part about the dimensions of the equation? Anyone having a question or a doubt till this point?
Yes,
So you're not supposed to solve, you have to write the units here till this, and then you have to work out the dimensions. Look, till this point, we work out the units. You don't try to solve the units, you solve by dimension. You have ms, this was m by s plus m by s, okay? And if you try to solve, don't try to solve the units. After writing, like simplifying the units, then you have to write the dimensions. So here m by s means the dimension is L by t. Here the dimension is L by t. Here the dimension is L by t. You can write in fraction or you can write in numerator at the last. Now, after simplifying the unit, we write the dimensions and then we simplify the dimension only. We don't simplify the units. So if we take t as an LCM, it will be L plus L. L plus L, we don't write L plus L as 2L, we write L plus L as L. And you can say LT minus 1 on the left-hand side is same as LT minus 1 on the right-hand side. So this equation is dimensionally correct. So about a minute left, I'll share another link.